All right, so the first part is solving. If you get problems that look something like this, we have 4 to the 3x power is equal to 8 to the x plus 1 power. So if we have two numbers that are both raised to powers, and the x, what we're solving for, is in the exponent position, then that's what we call solving exponential equations. It's different than solving power equations, or things that are being raised to an exponent that is known, like x to the third power. That's when we take roots, right? This is different than that because we have x's that are in the exponent. Now, in this case, this is a special case because the 4 and the 8 can both be expressed using the same base. If that can happen, if we have the same bases on either side, then it would make sense that then the exponents would have to be the same. Because if it's an equation, right, and we've got two sides that are the same, if the bases are the same, then the exponents would also have to be the same. That's the only way that the equation could make sense, that it could balance. So with the bases of 4 and 8 right now, could we express the 4 and the 8 differently so that way they would have the same bases? How can you express a 4 and an 8 so that way they have bases that match up? Like, how can you express 4 differently so it has a different base other than 4? 2 squared. Does that make sense? So instead of a 4, I can call that 2 squared. Everything else stays the same, right? It's still to the 3x power. But now 4 is going to be expressed as 2 squared. You see, I didn't change its value. I'm just changing what it looks like.
Wait, so then 8 would be 2 cubed?
2 cubed, yeah, very good. But that's still to the x plus 1 power. See, now we have two sides of the equal sign that have the same exact base. If you can do that, that's definitely the easier route to go. Now, what do we do when we raise an exponent to an exponent? We multiply them. So that first one becomes 2 to what power? Yeah, because it's 2 times 3x, so that makes 6x. Now be careful on this next one. It is not 3x plus 1. 3x plus 3. We have to remember we have to distribute that 3 times the x plus 1. Make sense? All right, so now we have two sides of the equal sign. The bases are exactly the same. They're both 2's. So now we can say, well, then the exponents have to be the same. Does this make sense why we can jump to this next line? 6x is equal to 3x plus 3. If the bases are the same and the two sides are equal to each other, then the exponents would have to be the same as well. And now it becomes a very simple problem to solve, right? So now we just get our x's together and then solve, and we have a solution. Now, would it be important to check our answer? I would think so. We go all the way back to the original. All the way back up to the original problem, and we say, okay, well, if x is 1, 3 times 1 is 3. What is 4 to the third power? Everybody, come on now. 64. Let's put it on the other side. 1 plus 1 is 2, and 8 squared is also 64, and so it all checks out. Not bad? If you can get the two bases to match up, this becomes a very, very simple and common sense way to solve an exponential. Let's try this one. 2 to the 4x is equal to 32 to the x minus 1. So we have 2 to the 4x is equal to 2 to the 5. risen to the x minus 1. So this is 2 to the 5x minus 5. Right there is where that mistake usually happens because people forget to distribute. Don't let that be you. So 4x is equal to 5x minus 5. And then we solve and we get x is equal to 5. Let's go ahead and check your work. Now I know putting 5 in place of x, you get 2 to the 20th power. And that's going to be a really big number. Right? 4 times 5 is 20? Well, that's going to be way bigger than 400. Okay. So if you take out the calculator that you have in front of you and raise 2 to the 20th power, you'll probably get something that's in scientific notation. And that's okay. You don't have to write it down. But you can just look at it for a minute and kind of remember what that number looks like for just a moment, right? You only have to remember it for a moment. Yeah, just look at it for a second. And then put 32 to the 4th power in and see if it is the same number, right? Put 32 to the 4th power. And it's the same number, so it checks out. So you don't necessarily have to write it down every time. But it is good to check your work always. Now, there was a problem I just saw on the SAT on a website that was called the 13 hardest problems on the SAT ever. And this type of problem is related to it. And I didn't think it was all that hard. But here's what it looked like. It was multiple choice. I won't even give you the multiple choice options. This was on a website called the 13 hardest SAT questions ever. Ever.
Do people memorize SAT questions?
I do not. But I saw this one and I'm like, maybe it's because...
When they go into the test and they take it, do they memorize it so when they get out of the test they can figure it out, or like?
This was from a retired test. So this isn't one that, but there might be one similar to it. But this was one from a retired test. And it said, if 2x minus 3y is equal to 10, okay, then what would be the value of 4 to the x over 8 to the y? Now, listen, it's related to what we just did. It's related to what we just did. Can you express 4 and 8 with the same base? Okay, so how can you express 4? 2 squared. And 8 could be expressed as 2 to the 3rd. All right. Raise power to power, you get 2 to the 2x. And this is 2 to the 3y. Okay, now bases are the same, right? And it's being divided. What do you do with exponents when bases are the same and you're dividing? Oh, you subtract them. Okay, so 2 to the what power? What do you... all right, subtract. So what do you get? What expression do you get when you subtract? 2x minus 3y. Do we know what 2x minus 3y is? Oh. That's the answer, and that's one of the answers listed. Since 2x minus 3y is what you get when you subtract the exponents, and they define 2x minus 3y is equal to 10, and that's one of the multiple, and this is multiple choice. I didn't give you I haven't memorized the 4 answers that were multiple choice answers, but I remember seeing this just this weekend, and I thought, it is tricky. I will give them that. But one of the 13 hardest questions ever written on the SAT? I don't know about that. Now, granted, I'm living in Algebra 2 land every day, and we're doing chapter 8 right now, so I'm kind of hoping that one of these questions ends up on the SAT for you in a couple weeks because it's fresh. You know, you guys are like living in chapter 8 right now, so I would think you could have a chance to get this one right. You know, by using your exponent rules that you all know. I don't think that is necessarily one of the 13 hardest questions I've seen. I've seen way harder ones than this. But
Can you write one?
no, I can't, because I've seen some tough ones for sure. Tough ones for sure. All right, but any questions about rewriting a number so that way they have the same basis? You have to be familiar with powers of numbers. I would be familiar with your powers of 2 up through 5 at least, right? And just know 2 to the 4th power is 16, 2 to the 5th is 32. You can double and count up from there on your fingers. That's fine. You should know 3 to the 2nd, 3 to the 3rd, 3 to the 4th, right? Definitely. And you should know 4 squared and 4 to the 3rd. 4 to the 3rd is 64. You should know these numbers because they tend to show up in problems like this. All right. So that is rewriting using the same base. Yes, sir.
SAT question.
Yes.
Do we have like a set limit of scratch paper we can use?
They do not give you scratch paper, but you can write all over the test booklet itself, and they usually give about, I would say 60% of the page would be blank for you to write on.
Wait, so do you have any like extended response questions for math or like